Let's have a look at the mechanism for the radical substitution. Remember, this is the halogenation of an alkane to form a haloalkane. I'm going to go through the example where we're looking at methane reacting with bromine to form bromomethane and a hydrogen bromide molecule. But remember that in an exam, they're likely to give you a more complicated alkane than methane, and they might try and confuse you by getting you to chlorinate rather than brominate. Did you remember that the radical substitution mechanism has 3 stages to it? The first stage is the initiation, the second stage, the propagation, and the final step is the termination. So let's go through these steps one by one and find out what happens at each stage. In the initiation step, we start off with our bromine molecule. A bromine molecule is 2 bromine atoms joined together by a covalent bond, where a covalent bond is a shared pair of electrons between the nuclei of the bonded atoms. Remember that covalent bonds can undergo 2 types of bond fission, that is homolytic fission and heterolytic fission. In this case, we have homolytic fission, where the pair of electrons in the covalent bond split so that 1 electron goes to each bromine atom. So we form 2 bromine radicals. Remember that breaking bonds is endothermic and making bonds is exothermic. So in order to break this covalent bond, we're going to need to put some energy in. And that energy will be transferred from the surroundings to the system. And this energy comes from UV light. We then move on to the propagation. The propagation stage or steps happen in 2 stages. In the first step, the alkane, which in this case is methane, reacts with the bromine radical that was formed in the previous step. When they react together, we form a methyl radical and we form our hydrogen bromide molecule. In the second part of the propagation, our methyl radical reacts with a bromine molecule to form our haloalkane and a bromine radical. You might notice that we use a bromine radical in the first step and we produce a bromine radical in the second step. The bromine radical acts as a catalyst. The final step we need to talk about is the termination. The termination occurs when 2 radicals react together. This could be 2 bromine radicals reacting together to form a bromine molecule. This could be a bromine radical reacting with a methyl radical to form a haloalkane, or it could be 2 methyl radicals reacting together to form another alkane. In this case, ethane is formed. Remember that a radical substitution is a chain reaction and further substitution can occur.